Hello, everybody, and welcome to today's webinar, That's Not How This Works, All Development Should Be Secure Development, brought to you by Synopsys. I would like to introduce to you our presenter, Jonathan Knudsen. Jonathan is a technical evangelist for Synopsys and also teaches a class about secure software development at Duke University. Jonathan likes to break things. He has tested all kinds of software from network infrastructure and medical devices to cryptocurrency nodes. Jonathan has worked as a developer, consultant, and author, and he has published books about 2D graphics, cryptography, and Lego robots, and has written more than 100 articles on a wide range of technical subjects. So with that, we'll go ahead and get started. Jonathan, if you would like to take it off.
Excellent. Thank you very much. So thanks to everyone for joining today. I hope you'll find it informative. I want to start by going through the outline of the talk today. So I'm going to start by talking about how software is created, and then what could possibly go wrong with that process. And then I'll briefly touch on a related problem, which is if you're buying software products, what can go wrong with that as well. And then if I've gotten you sufficiently depressed, I'm going to sort of turn the corner there and talk about secure development lifecycle and how that helps people build better software. And then we'll talk specifically about what you can do during that lifecycle in terms of more testing and better types of testing, and also how that relates to buying software. So there are types of testing that you can do to help you understand what you're buying better. And then we'll take a step back and talk about a world with unicorns, sort of how the best case scenario of how organizations can marshal their resources to deal with software security. And then I'll close out with some remarks about, where do we go from here? So overall, the point of the talk is to look at how software is made and how we can do that better, and kind of how you can capitalize on some of the things that people have learned about software development over the past decades. They've learned them the hard way, and hopefully you'll get a sense of how you can approach security in your organization and do it better and more efficiently. So we're going to start with a look at how people make software. And to kick this off, I want to give you this idea that anyone can cook. And this is a very democratic idea where anyone can go to the store and buy some food, some various food items, and bring them home and put them in a pot and apply heat and make something. And similarly, anyone can write software. So as long as you have a moderately priced, moderately powered computer and an internet connection, you have everything that you need to learn how to write software. The problem is not everyone's a good cook. And so while it is very easy to create software, it's actually rather hard to make software that's robust, that's secure, that is safe. And so that's the idea of this talk. For many organizations, kind of the short game of creating software looks like this. And only two things matter. You want to make something that works. You need some features that matter to your customers, and you're trying to get it to market as fast as you possibly can. And so this picture, I think, really sums up what a startup looks like for many of us. So the raccoons on the front, that's the sort of visionary founder with a just unshakable optimism in whatever it is that they're doing. And the squirrel hanging off the side there with that same kind of optimism, I would imagine that's probably marketing or sales there. And the turtle probably represents finance or the legal team or something like that. But at any rate, you've got this big bundle of stuff, and you've strapped a rocket onto the back of it, and you're just going as fast as you possibly can. it's a very good picture of a startup, but I think it also accurately captures larger organizations when, for example, they're developing a new feature for an existing product. I think they have the same kind of urge to get it done as fast as possible and make something that has value to customers. So whoever you are, it doesn't really matter. The fundamentals of software development, there are really only four things. So you decide what you want to build, and you decide how you're going to build it, and then you build it, and then you test it. And if you're passing your tests, you release it. And so I'm going to say a few words here about different development methodologies, because you'll hear people talk about these in you know, sort of hushed, respectful tones. And for me, they're just sort of different twisting ups of these four fundamental steps. So if you look at, here's the classic waterfall picture that I pulled out of Wikipedia, and this is the one that everyone sort of knows, where you do the steps very linearly. So you start out deciding what you're going to build, you make the requirements for the document, and then you design it, and then you actually build the thing, the implementation, and then you test it in verification. And then if everything goes right, you release and you go into maintenance mode. And everything's very, very linear. And nobody really builds software this way, but newer methodologies are really just kind of twisting these same steps around into different shapes. So a big one these days is DevOps, which is rapidly becoming DevSecOps, and put the security inside of it. But if you follow this infinity sign around, it's essentially the same steps. You know, decide what you want to build, figure out how you're going to do it, build it, test it. And likewise for Agile methodology, really the same steps in a different shape. So, software methodologies definitely matter. They're important in how you organize your teams and try to efficiently use your time. But the point I'm trying to make is that it's essentially the same fundamental steps of software development, no matter what shape your specific methodology has. So, okay, so anyone can write software, and you're trying to go fast, and you've got, you know, the fundamental steps of designing and building and testing. What could possibly go wrong with this picture? Well, the thing is, when you're focused on functionality and you're focused on speed, you miss some stuff. And so specifically, one of the things you miss is you might not have software that has the quality that you want. Like, it might not always work right, or when you press the button, maybe the light doesn't always come on, or whatever it's supposed to do. And you might have security problems where attackers are able to exploit vulnerabilities to do bad things. And depending on your application, you might have safety problems. So if you're writing software for a nuclear submarine, or you're writing software for a medical device, if you have things that aren't working quite right, those can be safety issues in that context. But really, the reason I have this picture of the three-headed beast is that quality, security, and safety are all different heads on the same monster. And that monster is bugs in code, or also bugs in design. So if while you're making this product, you make a mistake, either in the design of it or the implementation of it, that's a bug. And depending on the application of the software, the consequences, you know, it might be reliability or safety or security problem, but it's essentially bugs. The other thing that you sort of lose in this mad rush to get to market is you're not managing risk coming from your software supply chain. And so just to introduce this idea, nobody really writes software from scratch. So developers will always pull from open source and other third-party software components, and sort of strap them together and maybe add some glue code to hold everything together as a product. But essentially creating software is a kind of manufacturing. And so the components that you're using have risk themselves. And so if you need to be managing that risk in order to minimize your overall risk when you're creating this product. So the security components themselves can have known vulnerabilities, and so you need to be aware of those, or making sure you're using updated versions that aren't as vulnerable. And the security components also have license obligations. So open source or other third-party software components have an associated license which dictates how you're allowed to use it. And so you need to be looking at that supply chain of software components to make sure that you're not using something that is incompatible with the way you want to release your product. So what's in the long game? So we said anyone can cook, or anyone can write software. Likewise, anyone can stack one rock on top of another. But what if you want to build something like this arch here? It's been standing for a couple thousand years. Just knowing how to stack rocks is not enough. So you need a wider range of expertise. You need people that know how to design this thing properly, how to make arches that don't fall down, how to assess the soil that you're going to place this thing on, and so forth. And likewise with software, it's not enough just to know how to write code in some programming language. You need a wider range of expertise to achieve something that lasts. You're looking for resilience. You want to make things that are secure against attack. You want to make things that are robust in the face of unexpected weirdness out in the world. And why does this matter? It matters because we're using software for so many different things in the world. And so the risks and the consequences for your software development are, I guess, kind of dramatically shown here with the 4 horsemen of the apocalypse. But I think it's really not possible to overstate how important this stuff is. So a lot of people think to themselves, well, I'm just writing software for X, and nobody cares about X too much. But what you'll find is that the world we live in is built upon, thousands of pieces of software that might not seem that important by themselves, but put them all together, and it's essentially like a kind of a critical infrastructure. Okay, so that's pretty scary, right? So now let's take a look at buying software. So that's all from the perspective of making software. If you're making a software product, how do you, what are the risks, and where are the risks coming from, and what are the consequences? On the flip side of that, what if you just are buying software products and want to use them? And this is similarly scary. So I'm going to present a few different sort of industry areas. But essentially, when you buy a piece of software or a piece of equipment that has software running inside of it, it's one of these big question mark boxes. You just really don't know what's inside. So think if you're a bank, you want to buy a web server, you want to buy network equipment for your infrastructure, you need something to authenticate people, and so forth. How do you know what's inside? And obviously, these things that you're buying are critically important to your business. Likewise, with a hospital, you've got patient record systems, you've got things like infusion pumps, or patient monitors, bedside monitors, or big things like MRI machines. And how do you know what you're getting and how to minimize the risk? For a general enterprise, same problems, different products, but the same problem. How do you minimize your risk when you're buying and using things? And then finally, from the consumer point of view, think about your house. How many devices do you have hanging off your Wi-Fi network? And do you know anything about how secure they are? Do you have any idea what kind of risk they present to you? So it's tough. So how do we address this? Again, from the builder standpoint, for people who are building software products, secure development lifecycle is really the answer to this. And the key to this is finding and fixing more bugs during your development process sooner. So like the pirate code, it's not really a specific thing so much as sort of a state of mind. And remember, we looked at the 4 fundamental elements of creating software products, and let's revisit those. So for the secure development lifecycle, you're just thinking about security all the way through. So it's really kind of the same set of things. Decide what to build, but you're thinking about security when you do that. Decide how to build it, but you're thinking security. Build it and test it, both with security in mind. And so it's just more of a overall mindset rather than any fundamental change in how you are building your software. There are some new elements as well. So education is an important one. You want your developers, you want basically everyone in your organization to understand what the challenges are of software security and how to address them. And then within the product development lifecycle, there's more testing and better types of testing. And we're going to dive in and talk specifics about that in a minute. And then likewise, you also want some sort of incident response. And so the idea is, if you're making software products, no matter how careful you are, things will always go wrong security-wise at some point with your released products. And so you need some resources and you need a plan for how to effectively respond when things go wrong. And that's called incident response. So a great example of a secure development lifecycle comes from Microsoft. And they really did a kind of a dramatic turn. It was kind of like watching an ocean liner execute a nimble 180-degree turn. And this was around, I don't know, 2001, 2 maybe. But they could see that they were having a lot of trouble with their products from security, and that they needed to change how they did things. And so they came up with this thing, they call it an SDL, Secure Development Lifecycle. And you can go look it up. It's they have a fair amount of public information about what that means to them and what the activities are that they use for that. So you can go read about it, but I've summarized it here. Microsoft presented it as 12 different practice areas, and I've just grouped those into a few different things. So the first one is the training that we talked about a little bit. The last one at the bottom is about incident response. And then all of the other practice areas that Microsoft defined can sort of be grouped into, always think security all the way through the software development process, and do more and better testing while you're in that development process. All of this is really a fairly simple idea, which is find more problems sooner, which is like the old saying, a stitch in time saves 9. If you do something right earlier, you invest a little bit of effort and do it better earlier, then you're going to save yourself a big mess later. And so in the world of software, this is really find and fix more bugs earlier in your process, or before product release, and it makes a big difference. So again, the consequences kind of depend on what the application is, but in general, you're going to save money because it's cheaper to build things securely than it is to try to patch them up later after bad things happen. And you're reducing your risk of litigation. You're reducing your risk of reputational damage to your organization, and you're making your customers happier because your products are more reliable, they're more secure, they're safer to use. So one of the things I like about a secure development lifecycle is that it kind of lets everything be in the right place. So we've said security's a part of every step of this process. And so from a builder standpoint, from somebody creating a software product, it just helps you create better products. They present lower risk to your customers, which means your customers are happier and there's less chance that bad things will happen and you'll be responsible. From the buying standpoint, if you're procuring software, you need to find a process that helps you minimize the risk. And so we'll talk a little bit about how you do that in a little bit. But with the SDLC, the Secure Development Lifecycle, it lets your higher ups in your organization make risk-based decisions about policy. So, for example, if you're creating an infusion pump, you could have some informed person decide what your security policy is for making that pump, like what types of testing does it have to pass successfully, and if you're looking at the software supply chain, what kinds of third-party components are we able to use in this? And then likewise, the development team gets to do what developers do best, which is creative solutions to hard problems. And so they go about their way. They have some increased awareness of security because they've been trained, but the process that's surrounding them is helping them produce better products. So they've got more testing going on, so they have more things that they're going to have to fix. But from their standpoint, they're not bearing the full responsibility of making secure products. They're now inside a process that helps them make secure products. And one of the things that we'll talk about in a little more detail is the actual tools that you can use, security testing tools that you can use to support this process. So you can train your developers, but even the best developers are going to make mistakes. And so having automated security testing as part of your SDLC helps, just supports them in making sure that you're finding and fixing more bugs before you release a product. If you're purchasing software products, how does this help you? So I've been talking, going on and on about how great the secure development lifecycle is and how it helps you make better products. But what if you're buying stuff? So I don't know if it's directly helpful, but at least you know what your vendors should be doing. And this means that before you actually sign on a dotted line and fork over some money for a product, you can ask a lot of tough questions of your vendors. So, and they're not even that complicated. You can just say something like, well, tell me about your secure development lifecycle. And if they have trouble answering that, then your riskometer is going off in your head. But if they're okay with that, then get more specific and say, okay, what kind of X security testing are you doing? Fuzzing or static analysis. And if they're okay with that and they're doing testing, then you can go more detailed and say, okay, well, what's your policy? What's acceptable results for this product? And maybe, depending on how much money you're spending or how much risk this particular product represents to you. Maybe you say things like, well, okay, can you show me the security testing results? I'd really like to drill down to that level of detail. And so these are all things, conversations you can have with a vendor to help you assess risk of something that you're buying. And then in addition to that, there are some security testing tools that you can also run yourself and get your own results. So this brings us sort of into the better testing and more testing section. So this is, again, in the context of the SDLC as part of whatever software testing you're doing for functionality. You also add in these additional types of security testing. So the categories of tools are as follows. So the first one is what's called SAST, which is really kind of an awful name. It stands for Static Application Security Testing. But when people say SAST, what they really mean is source code analysis. And this is a class of tools which are pretty cool. They're automated. They're fully automated. So they basically read through the source code of the product that you're building, and they look for bugs. They look for things that don't look right or will probably cause trouble. For example, if you've constructed logic where some portion of the code is unreachable, or you've allocated something and then never freed it, or there's like an exceptional condition where it doesn't get freed, or you're using some pointer to memory after it's been freed, or so on and so forth. And these tools range from fairly simple to very complex in their ability to understand code and interpret it and find probable bugs for you. So that's one big category. Another big category is called software composition analysis. And this is where you're looking at that supply chain of software components that you're using in your product. So it allows you to examine that list of components, which is called a bill of materials. Allows you to track what's in your software, what the versions of all these components are, and then more importantly, what are known vulnerabilities associated with those components, which might be exposed in your product, and also what are the software licenses for the third-party components, so that you can make sure that you're not using components that have licenses that are incompatible with how you want to release your product. So that's software composition analysis. Fuzz testing is another important security testing technique. The idea here is that you, it's kind of the opposite of functional testing in a way. So in functional testing, you're just making sure that everything works right. You deliver valid inputs to your software, and you look for the right output. So, if I press the button, does the light come on? Or if I submit this input, do I get the right output? Does the right thing happen? So fuzzing turns that on its head, where with fuzzing, you are creating deliberately malformed inputs, like inputs that are kind of right, but a little bit wrong. And you're delivering them to your software and seeing if something goes wrong. You're seeing if some failure is triggered. It's also called negative testing. And you do this hundreds of thousands or millions of times, where you create all these badly formed inputs and throw them at your software and see if it does something wrong or it fails in some way. This is a favored method of attackers who want to discover vulnerabilities in a piece of software. And then the final category I'm going to talk about today is called IAST, or Interactive Application Security Testing. And this is a technique that's used for web applications specifically, where the test tool sort of attaches itself to the server where the application is running. And then as you run through your regular functional testing, it's looking at the inside of the server to see how the incoming data is being processed and things that could go wrong there. And so it figures out vulnerabilities that way as well. So these are not the only categories of security test tools, but these are some of the big ones that I wanted to introduce to you today. So again, this would all be inside the context of the secure development lifecycle, and this would be for organizations that are building software products. If you're buying software products, you can actually use some of these tools. So I grayed out the ones that you can't use. So of course you can't use source code analysis because it's your vendor's product and they probably don't want to share their source code with you. However, there is a flavor of software composition analysis, which is capable of scanning binaries rather than source code. And so it's possible for you to do some software composition analysis on products you're thinking about buying. And that helps, that gives you some insight into the risk profile of the software bill of materials for that product. You can definitely do fuzzing on products you're thinking about getting. And again, that helps give you more information about the risk that you'd be taking on by purchasing the product. And depending on the product, you might or might not be able to also use IAST as a way of assessing risk. So at this point, I want to back up a little bit and talk about how security teams get implemented in organizations. And in the world that has unicorns in it, in the ideal world, the security team has support from the very top of the organization. And in fact, that's exactly what happened with Microsoft, where the ocean liner changing directions, that came down from Bill Gates at the top and had full support of the leadership at Microsoft. And that's partly why they were so successful in implementing that. So that's the world of unicorns. It's support from the top. And then there's somebody, probably a CISO, a Chief Information Security Officer, who's in charge of the security team and has ownership of the three functions of product security, which is mostly what we've been talking about today, IT security, which is kind of the the buyer side that we were talking about today, and then also incident response. And in this ideal world, that CISO has the authority to get stuff done. So they're able to be like a thought leader for the rest of the organization. So they design organization-specific SDLC, and they help push that out into the product teams. They figure out what policies are for making software and acquiring software, and they're able to, they've got the teeth to make it stick throughout the organization. Of course, we don't live in that world with the unicorns. We live in a world with donkeys instead. And so frequently the way security works its way into an organization is, as the expression goes, bass ackwards. And so the organization will say, okay, we need a security team. We've been reading the headlines, we're a little bit scared, and we know that we need a security team. And so they create a security team, and they might or might not have really full support or the authority they need to make things happen. And the rest of the organization sort of says, okay, we've got a security team and they treat it like a risk bucket, and they pour responsibility for all of the risk into the security team, which is exactly the wrong model. So the security team should be spreading outward, helping the product teams adopt an SDLC and so forth. But frequently what happens is that the product teams will be almost done with a product, and then they'll send it over to the security team for testing, which is a bottleneck because there's only the one security team. And the security team will run tools on the product, and they'll find stuff, and they'll tell the product teams they have to go fix these things. And the product team feels like the security team's just getting in the way of their getting the product out the door. They're slowing them down, and they don't really understand what the security people are so worked up about. And it's an antagonistic relationship, and it's not scalable because all of the testing is being done inside the security team. So, so the way that this gets better, how does this get better? So let's look at that. And so it's definitely good that organizations are realizing they need a security team, but they have to treat them differently. So they have to look at the security team as thought leaders and evangelists in a way to help the rest of the organization become more secure. And so if we were going to do a medical analogy, you would say rather than being a bandage on the organization, your security team should be more like a vaccine, where they spread throughout the organization and help make every part of the organization stronger. So so that's the vision. That's the idea that hopefully gets us from donkeys to unicorns. And so I just want to wrap up with a few thoughts. Anyone can make software. I mean, anybody can make software, but it's a much larger challenge to make great software, or even good software, even software that's reasonably secure, reasonably safe, reasonably robust. It's quite a bit harder, but it is possible. And again, software has been around for 50 or 60 years, and a lot of people have learned a lot of hard lessons. And now that we sort of know how things should look with a secure development lifecycle and the automated testing that goes along with that, you don't have to learn that the hard way. You can just go ahead and work towards implementing that. On the buyer side, if you're acquiring software products and you want to minimize your risk, just really maximize that procurement cycle. So ask a lot of direct questions of your vendors to make sure that they're developing their software correctly, and do your own independent testing whenever possible, so that you can so that when it comes time to decide whether you're going to buy this product or that product, you can make a pretty well-informed risk-based decision about that. And then for everyone who's building software products, the whole idea is to minimize your risk by finding and fixing more bugs before you release the product. And the earlier, the better. So we talked about the 4 different types of security testing tools. So there's source analysis, which essentially reads source code and finds bugs. There's software composition analysis, which finds vulnerabilities in third-party components and also looks at licenses. There's fuzz testing, which delivers intentionally bad inputs to software and looks for failures. And then finally, there's interactive testing, which looks at how running web applications behave and what the vulnerabilities might be in those. And so with that, I'm going to finish up. Thank you all for attending today. I really appreciate it. And at this point, I think we're going to pause and see if we have any questions.
Yeah, so it looks like we have 3 questions for you, Jonathan. So the first, I only have a budget for 1 security tool this year. What should I get?
That's actually, I hear that a lot. I think what you should get is a bigger budget, but we hear that a lot. Like organization has just created a security team and they're kind of trying to get it off the ground, and they're like, okay, well, we can't do everything at once. Let's get one tool. So if you were building software, a lot of people start off with source analysis or SAST, and part of the reason is that it fits so well into a developer environment, and so if the security team is just starting out and is not very mature and not really ready to buy tools and push them out to the rest of the organization, an individual development team can pretty effectively get source analysis tools and get them integrated into their development lifecycle. So that's a great place to start, but really any one of them is good, and the main thing is just to get started and move on from there.
Awesome, thank you for answering that first question. The second question is, can you tell me more about SCA?
Sure. So software composition analysis, the idea is that everybody who builds software is using parts, essentially, software components that come from third parties, often open source, but also commercial software components. And so, for example, if you were going to create an Internet of Things device and you wanted to communicate over TLS, transport layer security, nobody implements their own TLS. You'll go and you'll get some open source component that does it, such as OpenSSL or Matrix SSL or one of the others, and then you'll just simply use that component as part of your product. So SCA is all about tracking that software bill of materials, all of those components that you're using, and minimizing the risk from either known vulnerabilities in the components or software license terms in those components.
Awesome, sounds great. Thank you for answering that question as well. So your third and final question that we have for you today is, what kind of applications can be tested with IAST? So
IAST is specific to web applications, and the idea is that the web application runs inside of a container, and so the IAST tool is able to attach to that container such that when you do your normal functional testing on the web application, the IAST tool is going to see those requests coming in and see the responses going out. And just based on that and how the IAST tool is able to observe the inner workings of your application, it will come up with a list of vulnerabilities that are present in the application. And it can do nice things like replay requests to verify that the vulnerability is really there. But I guess the main answer is IAST is good for testing web applications.
Awesome, thank you so much. So with that, I would like to thank Jonathan for a great presentation. I would also like to thank Synopsys for providing the audience with a great webinar today. Lastly, thank you to everyone who attended today, and we hope you learned something new that will help you in your developer career. Have a great rest of your day, everyone.
Thank you.